Hello, good to have you here with us again on Royal Tutors. And you're welcome to our GCSE edition, solvings of our GCSE editions. And in this segment, we're going to be looking at chemistry. Okay, we're going to be looking at chemistry and we'll be taking some foundational questions from June 2024, the Combined Science Paper 2, and we'll also be treating another Paper 1. Okay, so basically what we want you to take up from solving of all those questions is what are the things the examiners are expecting from you when it comes to solving questions. Okay, when it comes to solving questions, there are key and salient points, all right, that the examiner wants to hear from you. So we'll be taking some selected questions in this particular series of video. Okay, follow us. I remain Mr. Sampson, all right, your tutor with the Royal Tutors. Now let's go on. Let's pick some questions. Don't forget, these questions are selected. This is a 4 marks question. 4 marks question. And prepare the solution. I want you to just follow up and see the concept of how is expected of us. Okay, first and the most basic thing is that you need to have a good and proper understanding of the questions, okay, before going on to solving them, before going on to answering the particular question. Okay, now this is question 5.2 of that year, 5.2, and the question says drinks cans are made from aluminium, and aluminium has a mass of about 1.8 grams. Okay, so 1,000 grams is what makes 1 kilogram, right? Yeah, 1,000 grams is what makes 1 kilogram. So calculate the whole number of aluminium cans that can be made from 4 kilograms. So like I said, it's a 4 marks question. Okay, so don't forget the parameters. All right, aluminium, the mass given here is 15.8. all right, then we are calculating the whole number of aluminium cans that can be made from 4 kilograms. So solving it, first and foremost, we need to understand that we need to convert, okay, the 4 kilogram to grams. And don't forget that 1,000 grams make a kilogram. So we're going to multiply 4 by 1,000. So 4 multiplied by 1,000 gives us 4,000 grams. So now we have 4,000 grams. How many numbers of cans do we have? All we just need to do is to divide, okay, to divide our 4,000 grams by 15.8, which was given. Okay, so are you puncturing with your calculator? Yeah, let's go on. So 4,000 divided by 15.8. 4,000 divided by 15.8. Are you doing that? Yeah, we've got 253.16. But don't forget, the question says your cans should be in whole numbers. So you're going to approximate this. Okay, 253.16 will give us 253 numbers of cans. So our final answer is 253. 253. Don't forget, first and foremost, you need to convert your kilograms to gram. Then after converting your kilograms to gram, just divide by 15.8. Yeah, you can see that, right? With this, you've gotten your 4 marks. With this, you've gotten your 4 marks. You've gotten your 4 marks just doing that. All right. Okay, so this is also another 4 marks question. Under hydrocarbon and petroleum chemistry. Yeah, this is I'm sure you're trying to remember, yeah, how this goes, right? Yeah, so this one says, explain how crude oil is separated into fractions. Explain how crude oil is separated into fractions. It's also a 4 marks question. And most of the time when you're given a 4 marks question, at least give minimum of 4 points. Okay, because each point is for a mark. Each point is for a mark. So since the question is a 4 marks question, it's expected that you give a minimum of 4 points. Okay, so the first thing that happens here is that the crude oil is heated. All right, the crude oil has to be heated. Okay, you know, like I said, this is chemistry of hydrocarbon. Okay, after the crude oil is being heated, you know, that's some of the hydrocarbons, of course. Okay, it's being heated, then vaporization will take place. So after vaporization, the column will have a temperature gradient. All right, the column will have a temperature gradient. So what is the need? Why is the volume having why is the column having a temperature gradient? So that the hydrocarbon will condense into different heights. Okay, so this is an industrial process that takes place. So the hydrocarbon will condense into different heights, all right, and into different temperatures. Okay, so once you're able to say this, or you can as well say, oh, the hydrocarbon fractions will condense at their boiling point. Once these 4 steps have been mentioned, you are good to go, right? Yeah, you are good to go. So now let's take a look at another question. This is very simple. Yeah, but it's just 2 marks, and 2 marks is part of it. Okay, 2 marks is part of it. Now this question is question 6.5, question 6.5 from this particular past question, and the question says describe the test for alkenes. Can you tell me how that is? Very simple test. Just give the result, okay, and say what you need to do. The test for alkenes is one of the simplest tests in chemistry. I'm sure you can remember now, right? So the first thing you need to do when you are testing for alkenes is to add bromine water. Okay, so when you add bromine water, what is going to happen? Your bromine water will change, okay, from the usual orange color to colorless. The bromine water will change from the usual orange color to colorless. So that will tell you, oh, this is an alkene. All right, this is an alkene. So once this is done, you know you have an alkene. You know you have an alkene. Now, let's look at some questions from May 2024. Okay, like I told you, we are selecting some of these questions for you to know what exactly is the examiner looking for, what exactly is the examiner expecting from you. And from that of this year, we'll try to tackle some calculation involved questions as well. So this is a combined science trilogy, May 2024. We extracted some questions from there, and this is paper 1. Okay, the last one we treated was paper 2. So this is a paper 1 question. So follow me as we'll go. All right, so let's take a question. This is a 2 marks question, but it involves you understanding. Like I said, you need to have a proper understanding of what the question entails. Okay, that will enable you to do well as far as that particular question is concerned. All right, so now let's take a look at this question. The question says, this question 4.2 from year 2024, it says, 2 of these ions are formed when a water molecule breaks down. 2 of these ions, don't forget ions. So 2 of these ions are formed when water molecules break down. So the symbol when a water molecule breaks down, we've been given the symbol already. H2O is our water, okay? We have hydrogen plus, then OH minus. So how do you complete this? So complete the word equation for the breakdown of a water molecule. Complete the word equation for the breakdown of a water molecule. Now, what is this telling us? Okay, how do we break this down in word? All right, H2O has been given to us here as water. H2O has been given to us here as water. So what do we call this ion? And what do we call this ion? That is just what the examiner is expecting from you. So the moment you can say this, already you have your 2 points, okay, your 2 marks. Good. What exactly are we expected to say? As simple as possible. Water equals to hydrogen ion H plus, okay, plus hydroxide ion OH. Do you get that now? So this, saying hydrogen ion, you have 1 mark. Saying hydroxide ion, you have another mark, making it a total of how many marks? Making it a total of 2 marks. So once you're able to do this, you've gotten your 2 points. Very interesting, right? Yeah, let's move on to some other questions. Okay, so this question says, now this question 6.2 from 2024, 6.2. So this also is a 2 marks question. And the question says, name an indicator that could be used to test if the solution is acidic. All right, name an indicator that could be used to test if the solution is acidic. Don't forget what indicators are used for, and we have quite a number of them. Okay, when you're checking for the pH, all right, whether it is acidic or basic or alkaline, as the case might be. So you have to give the result for the test. Okay, this is a 2 marks question. So what is expected of you is to mention the name of a particular indicator, then what is going to be the result. Okay, the indicators that shows us that a particular solution is acidic. And don't forget, from your pH scale, for you to know the solutions that are acidic, that's from 0 to what? Yeah, if you say 0 to 6, yeah, you're correct. Even 6.9. But from 7 is what? Is at the neutral point, but from 7.1 down to 14 is alkaline or basic. All right, so we have, can you mention some indicators you know? Yeah, I know phenolphthalein, okay. Yeah, you can say the litmus paper, okay. Which other one? Methyl orange, okay. All these are indicators, but which one do we use to test if a solution is acidic? We can use the universal indicator. If we use the universal indicator, our result is going to be from green to red. Okay, it's going to be from green to red or orange if the universal indicator is used. So if you say universal indicator, that's correct, and the result is from green to red, that's also correct. That is a total of 2 points. Okay, you can also use the litmus paper. Okay, when you use the litmus paper, the blue litmus paper, all right, the result is that the blue litmus paper will turn to red if it is acidic. All right, the blue litmus paper will turn to red if it is acidic. We can also use methyl orange. Okay, we can also use methyl orange. All right, so from the word methyl orange, you know the color is orange, right? Yeah, so but for you to, when you use methyl orange as an indicator, you will discover that the result will be that it will turn from red, from orange, okay, to red. Okay, so any of this is correct. If you use a universal indicator, the result will be from green to red or orange. So if you use the litmus paper, okay, the result will be from blue to red. Using the blue litmus paper, it will turn red to show that it's in an acidic form. All right, then if you use the methyl orange indicator, the result will move from what? It will turn from orange down to red. If you choose any of these, you're correct. So you're going to get your 2 marks, your full 2 marks from that. All right, now this is a huge one. Okay, looking at this question, you could see that this question will give you 6 marks. 6 marks. And so like I said, you need to have a prompt understanding, okay, of what the question is. Now this particular question is for 6 marks, okay, and it's a practical question. All right, so take a look. Now this is question 6.6, okay, this is question 6.6. Now it's showing a particular figure. So we have, in that particular question, we have the following equipment, okay. Yeah, the measuring cylinder, we have the gas syringe drum, okay, we have the conical flask, then we have the digital scale. Okay, so the student investigated the volume of carbon dioxide produced when different masses of calcium carbonate react with hydrochloric acid. Now, don't forget again, these are the apparatus, okay, that the students use in conducting this particular investigation. We have the measuring cylinder, we have the gas syringe, we have the conical flask, we have the digital scale. All right, so the student investigated the volume of carbon dioxide produced when you use different masses of calcium carbonate to react with hydrochloric acid. Now, what exactly is the question and what exactly are you expected to do here? The question is, describe a method the student could use. Okay, you're to describe a method the student could use. All right, now, and in describing the method that the student could use, also bear in mind these four apparatus: the measuring cylinder, the gas syringe, the conical flask, and the digital scale, okay, that has been drawn and given in that particular question. So we have a minimum, like I told you earlier on, is the 6 marks question. So you have to give in sequence, okay, in the same order. So you have to give it in the same order, and you must not have less than 6 for you to get your full 6 points as far as this question is concerned. Okay, so the first thing you need to do is to measure a stated mass of the calcium carbonate. All right, you measure a stated mass. All right, it could be 2.3 gram, it could be 3.2 gram, but there should be a stated gram. Then the next one is you use the balance. Okay, the scale, you use the balance. All right, you use the balance. Immediately after that, you add calcium carbonate into the conical flask. You add your calcium carbonate into the conical flask. So after adding your calcium carbonate into the conical flask, you measure the volume of HCl. You measure the volume of the HCl. Now, after measuring the volume of the HCl, of course, you measure that using your measuring cylinder. So you measure the volume of the HCl using your measuring cylinder. Immediately after that, you add the HCl to the conical flask. Don't forget, in the conical flask, we already have the calcium carbonate. The calcium carbonate is in the conical flask already. Do you understand that? So the calcium carbonate is already in the conical flask. So at this point, you're now adding the what? The measured HCl, the hydrochloric acid, into the conical flask. So immediately after that, then your stopper starts working. Okay, you place the stopper and the delivery tube into the conical flask. So immediately after that is done, you start taking record of the total amount of CO2 gas that is present. Now, you need to record the volume of the CO2 gas collected at each time, okay, in the set time. Or peradventure, you can also take note of the time taken to collect the fixed volume of gas, or you collect it in the syringe, okay, collected in the syringe. All of this process should be repeated. And what is the essence of repeating this process? These processes. The essence of repeating these processes is basically for you to ascertain, okay, for you to ascertain that what you're doing is right, because you will not get anomalous results. You see that they are what? They are following the same sequence. If you've done this, bravo to you. You already have your 6 points as far as this particular question is concerned. Yeah. Now, this is another question. This is question 7.2. And from now till the end, we're going to be looking at basically calculation questions, okay? How to handle some of these calculation questions when you come across them, okay? When you come across them. This is a very simple question, but it's 2 marks. Yeah, 2 marks is something, right? Yeah, let's go on now. Calculate the relative formula mass of sulfuric acid. Calculate the relative formula mass of sulfuric acid, which is H2SO4. Sulfuric acid, which is H2SO4. Now, don't forget, you've been given your relative atomic masses, Okay, oxygen, hydrogen is 1, of course, you know that, right? Oxygen is 16, then your sulfur is 32. So you have to calculate the relative formula mass of sulfuric acid. Now we move on to the solution. It's advisable you write your H2SO4. Yeah, when you have your H2SO4, you will know how to go about the calculation. Don't forget that the relative atomic mass has been given to you. Hydrogen is 1, okay? So because we have 1 hydrogen, that will be 1 times 2. How many hydrogen do we have in H2SO4? 2 hydrogen. So we have 1 times 2 plus, what is our sulfur? Our sulfur is 32 plus 32. Okay, don't forget oxygen, the atomic mass of oxygen is what? Is 16. Is 16. So how many oxygen do we have here? We have 4 oxygen. So that is why we have 4 times 16 in parentheses. Better. Okay, 4 times 16. So 1 times 2 will give us 2 plus 32 plus what we have here. Add everything together. What's your answer? Tell me what that is. Yeah, if you say 98, you are 100% correct. So you've gotten a total of 2 points, 2 marks, as far as this is concerned. Okay, so let's take a look at question 7.3. And that's huge. Question 7.3 is for 4 marks. Question 7.3 is for 4 marks. Let's look at this. Calculate the percentage by mass of oxygen in lithium sulfate. Lithium sulfate is written as this, okay? We are to calculate the percentage by mass. Like I told you, have a proper understanding of the question, okay? Having a proper understanding of the question helps you when solving, all right? Yeah, so the percentage by mass of oxygen in lithium sulfate. Okay, so we've been given the relative atomic mass of oxygen. Of course, you know that is 16, right? Yeah, and this has also been done for you. The cumulative relative atomic formula mass of the entire lithium sulfate is 110. 110. So you're to give your answer in 2 significant figures. This is simple, right? Yeah, this is simple. So for you to calculate the percentage by mass of oxygen, you can be told to calculate the percentage by mass of sulfur. You can be told to calculate the percentage by mass of lithium. But in this question, you're only told to calculate the percentage by mass of oxygen, which is 16. So, and when you're doing that, you have your mass over what? Your molar mass, okay, multiplied by 100. So what we need to do, take notes, okay? Yeah, then we have our relative atomic mass is 16. Then the relative formula mass for the lithium sulfate, we have what? 110. 110. So how many oxygen do we have here? Did you say 4? Yeah, that's correct. So we have 4 oxygen. So because we have 4 oxygen and oxygen is 16, so that will give us 4 times 16. Okay, 4 multiplied by 16, so which will automatically give us 64. Okay, so we have our 64 here. So then to calculate our relative mass of oxygen, we're going to have the atomic mass of oxygen over the formula mass, the relative formula mass. So oxygen now is a total of 64 divided by, what do we have here? 110. Okay, for the lithium sulfate, 110. And since we are looking for the percentage, we'll multiply by 100. Okay, so when you calculate everything, what are you going to have? 58.18. So you can leave it as 58.18%, okay, because you're told to leave the answer in 2 significant figures. So this is correct. This is correct. So your relative mass, you multiply by 4, and you're doing that because you have 4 oxygen here. You are doing that because you have 4 oxygen here. Okay, let's take a look at the last question for this particular slide. The last question, a solution of lithium sulfate contains 0.3 grams of lithium sulfate in 25 centimeter cube. A solution of lithium sulfate contains 0.3 grams of lithium sulfate in 25 centimeter cube. So calculate the concentration of lithium sulfate in grams per dm cube. Take note of this. It has to be in grams per dm cube. So don't forget So the first thing you need to do, you need to convert your volume from centimeter cube to dm cube. And how do you do that? That is going to be divided by 1,000. Okay, that is going to be divided by 1,000. So 25 divided by 1,000, that will give us 0.025 dm cube. Are you there with your calculator to confirm that? Is that what you just did? That's beautiful. So now for us to find the concentration, okay, for us to find the concentration of lithium sulfate, we've been given the mass as what? 0.3. So you divide your 0.3 by your volume, which is 0.025 dm cube. So when you do that, 0.3 divided by 0.025, what will you have? You're going to have 12 grams per dm cube. So if you've done this, you've gotten your full mark for this question, okay? If you've done this, you've gotten your full marks for this question. And at the same time, you can decide to use another approach, okay? You can decide to use another approach. You have your 0.3, okay, you have your 25 gram per dm cube. So from what you have here, which is your 0.12 gram per dm cube, which is the unit conversion. So all you just need to do is to change from the cm cube, you divide this directly, okay, 0.30 divided by 25. Once you have this as 0.012, you know it's going to be in gram per cm cube. So just divide this, just convert this cm cube to dm cube. How do you do that? You multiply by 1,000. So when you multiply 0.012 by 1,000, you have 12 grams per dm cube. You have 12 grams per dm cube. So I'm sure you've gotten value from what we've learned in this video. I can't wait to see you in our next video as we solve more questions. Keep tuning in to our channel on Royal Tutors. See you in our next video. Bye for now.